So since I'm the first speaker, I want to speak for everybody to thank Ronald for inviting us, to thank University of Hong Kong University for being so kind and so hospitable, and for the generosity that you've shown us and the attention. Last time I gave this talk, it took 2 hours, so I'm going to play a little bit to fit it in 20 minutes. Coming down here in the bus, Kevin, who's went all the way in the back. Kevin went all the way in the back. Told me to ask me some things about QCRI, and I figured I didn't have any slides. I was just going to go straight into Rayyan. So I inserted while I'm sitting there, just to show you, the Qatar Computing Research Institute is in the Qatar Foundation, and it's this first building here. And okay, and it's about it's one of 3 national research institutes. QCRI was started in 2010. We have about 140 staff from over 30 countries, all computer scientists, scientists and engineers, and we are divided into 4 departments. We work in NLP, especially focused in Arabic language technologies. We work in social computing, data analytics, and cybersecurity, and we also have an engineering team that does technology transfer. Okay, so that takes me to what I'm going to talk about today, which is Rayyan. Basically, Rayyan is a system that does systematic reviews. This is no research whatsoever. In fact, when we first started the project, and Siham was there years ago, one of my requirements is that we write no papers. So there are no papers written. We eventually have one paper written on this. The question is, there are many many medical claims, such as whether low-fat diet is better for you, or whether eggs are not or whether eggs are harmful, and so on and so forth. And it turns out that a lot of these claims are not based on any scientific proof. So what we have done is developed Rayyan specifically to try to find medical proofs by looking at medical literature and finding to substantiate such claims. And as it turns out, that many of these claims are not necessarily accurate or not necessarily correct altogether. So for higher consumption of eggs has no risks of extra coronary disease, except in specific patients with diabetes and so on and so forth. So we developed this system that's based on text mining that helps scientists do these systematic reviews. There is literature review that is focused on a specific research question. And systematic reviews are very commonplace in medical research institutions and hospitals and so on that do clinical trials. So if you do a clinical trial, you start with a set of questions. So you have a medical question, you identify relevant literature, you select studies that are relevant to this particular question. You then assess the quality of each study. Then you decide which ones that are relevant, which ones are not relevant. You synthesize from them, you interpret the answers, and so on and so forth. And the systematic review is a very clear process. There are organizations like Cochrane Foundation, for example, that is do this this is their bread and butter. They do this every day, and there is a very clear process. And what we wanted to do back when we started this work is to say which of these steps where we can introduce some automation to make the job of doing the systematic review faster, more accurate, and so on and so forth. So we knew that we don't want to do everything. We knew that we couldn't do everything, but we wanted to automate certain things. And in fact, we continuously, we receive input from people that do systematic reviews that rely on our system. And then we take their input and we add more features. And sometimes we have features that we believe are important. We remove them because people either tell us they're not useful or we don't find users. Our users are not typically using these. So the idea is that you, to run a clinical trial, you need to run through tens of thousands of articles, medical articles, literature that's published in open domain or at PubMed and things of that nature. You sift through these thousands of articles, and then you run collaborations between different scientists that also look at the same literature, and you label these studies, you track these studies to make decisions. You have all kinds of formats, you deal with duplicates and so on. So what Rayyan does is handles all of this in a very seamless way, and so my objective is to show you the demo, so I just wanted to give you some motivation. This is Rayyan, and Rayyan runs on all environments, runs on Windows, runs on iOS, runs on all kinds of operating systems, runs offline and online. Also, there's a mobile version that you can run disconnected, and so on and so forth. So it's a system that so it's a web app for systematic reviews. Features include things like intuitive user interface for screening articles and a support for review collaborations. So you can have, and typically you have multiple reviewers running the same things, and then allows article inclusion suggestions and things of that nature. And also, like I said, there is an offline version. So how does it work? Let me, maybe best to just show you a demo. I have, if I have a lot of time, I can go through this. But basically, you start with a screen that allows you to define a review. You define a review, you give it a name, you give it a description if you want, and then you create the review, and then you upload the literature. You either have already collected a set of articles that you're interested in screening, you upload that file, or you can go to PubMed and use the mesh ontology that helps you to select the literature. You create that literature, and then you go through it. And you can invite other reviewers to jointly do this review. So I'm going to try to do this online. Okay, so Okay, so basically, you have a okay. So you can, but I cannot see. Let me just go back to the. I ran an example study, and this is a study that I was interested in doing, and it looks at a question whether people with heart disease and diabetes, what's the relationship between heart disease and diabetes. And this is a study that had 2,045 articles. So what you have is you have a pane on the left that helps you include and exclude articles very quickly. First of all, there's the system identifies 57 articles as potential duplicates, and then gives you the ability to go through these articles and figure out the duplicates. So if you click on duplicates, it will show you both, and then you can quickly determine whether you believe that they are duplicates or not, and will eliminate the duplicate. So you go through the duplicate elimination, and then for inclusion, as you can see there is a set of keywords that come loaded in with the system for inclusion. So there's inclusion decisions. You can add more. You can add more keywords, and then you can either, when you look at a particular article, you can decide to include this article like this one. If it's included, this is the reviewer. It's marked in red. If it's excluded, it's marked in green. Otherwise, it's marked in red. And then you can exclude articles and so on and so forth. And then you can also choose the reason to include or exclude an article. So if you want to exclude an article, you can identify the reason, and then these reasons are also kept back here. And so there's some keywords that are preloaded in the system for inclusion and for exclusion. There's also, we keep track of the journals, we keep track of the authors of these studies, and then you can either include these or exclude these. And also you can create personal labels like these. So I can create personal labels that say, for example, I want to keep track of articles that have certain terminology like placebo, randomized trial, whatever keywords that I want, and then the system will keep track of those, and I can display those articles that have those keywords or not, and so on and so forth. So after the system going through several of these, let's say 100 to 100 articles, it learns enough, then it gives me, initially you will not see these ratings on the right. And then it gives me these ratings, and the ratings are either green or red stars. So it's 5 stars, and you can sort them by stars. And then this is the system input, and then the user at the end has to choose by going through, let's say for example, I want everything that has more than four green stars, that this I want to accept to be included in my review. And then those articles and the rest I want to go through. So there's very clear inclusion, there's very clear exclusions, and there are things in the middle, and I can go through these things quickly. There's also a keyboard. By the way, this is done for medical doctors and people in hospitals, so we include all kinds of help to them. So there is a keyboard help, and there is also help with the format. So the system, you can export, for example, once you finish the study, You can export these articles in any format. There is BibTeX, Riffman, whatever, EndNote, which is very popular. People import and export these files in EndNote, CSV files, and so on. You can export these, and again, there is, when you go to the export format, you can click and it has guidelines. There's help files for each one of these formats, how to input and how to export into those formats. So the system is very much geared towards making it easy for end users. The other thing is there is a another thing. There is we facilitate to allow the main reviewer to invite other reviewers. So basically, you go into the window and you put the email, say of Reynolds, and then I invite Reynolds and I give him some rights. These reviews are done completely separate, so the reviewers don't see each other's reviews until, so we have a blind on, a blind off, so the reviews are blinded so that different reviewers don't see the results until after the review is done. Then the person who's in charge of this review turns that blind off, and then they could share and they could see the review. Meanwhile, the person who's in charge of doing the review can keep track of how much work Reynolds has done, whether he has worked on this at all, how many minutes he's spent on this, how many articles he's reviewed, how many minutes he spent in every article, and things of that nature. So this is, I just want to show you, since this is a system that is, oh, by the way, I can also include the format from PubMed. And in PubMed, I go through the mesh network, and it allows you to join terms, and then within those terms, like for example, I want to do cancer and recurrence, and within recurrence, it comes loaded with some suggested terms. I can remove those terms, I can add more terms, and then it will bring that literature. See what other features that I want to show you, but I want to for sure, I want to show you some information about the usage. So this is a system that has over 28,000 users from over 50 countries. Most of the places that you can think of, this is the collaboration, and you can see it keeps statistics on the different reviewers and how much work they have done and so on and so forth. But I want to go to the, I want to go straight to the, let's skip all this architecture. Okay, so there has been an independent evaluation that's done by some people in Sweden at the Royal Institute of Medicine in Sweden, an article that was published reviewing Rayyan, and it basically reviews specifically Rayyan as a tool for doing systematic reviews. It is considered to be, these are testimonials that you can find from users. People like features such as being able to do the review offline on this. We get comments, for example, from somebody in India that says, I'm sitting on the train for the last 3 hours and I can do my work independently because you could work offline and then sync your work afterwards. So like I said, we have, by the way, we've processed over 30,000. This is now 28,000 users already. We have over 1,600 daily reviews that are done, that we keep track of. We have over 30 million labels, whether they include labels, exclude labels, user-defined labels and so on and so forth that we keep track of in all of these articles. In fact, we have more articles than PubMed. We've exceeded PubMed because in addition to the literature that you can get from PubMed, also people get other articles from Google or something like that. So this is a, by the way, we've only written one paper and it's by force. My rule was when we started this project is that we don't want to write any paper. We want to produce a system that is that has end users. We've written this article just to like a manual, and it has been the usage has been growing tremendously over time. I don't think you can see this, but this is really growing at a rate where we're growing by like 1,000 users a week, and it's sort of, you know, it's getting more and more. You can see that we keep track of the users of the system, and this changes every week depending on who's the top users for that week. For example, the last one, the US, and by country and also by institution. You will find Harvard, Stanford, Texas A&M, and so on and so forth are among the users. We have very big users based in, we have over 50 research institutions or hospitals in Sweden that use the system. And I just sort of wanted to condense, it was like a 2-hour sales pitch, so maybe I want to use this last 2 minutes to answer specific questions rather than, so this is a system that we started early on with a collaboration with PubMed, and then Murad and Hussam were the engineers behind it. I sort of, it was my idea originally, but they done most of the 90% of the actual work afterwards. What questions? Yes?
Does the system actually download the papers of the system, or is it remote?
Yes. So this is a very good point. Right now, we download the analysis is based on the metadata. There is the author, title, journal name, year of the publications, and so on. So the first screening is done based on that metadata. The second screening is done based on the abstract. We can download the full article if we do the analysis within, for example, within Qatar Foundation, because we have the subscription to the Qatar National Library. The problem with uploading the full article is that you need a subscription, whether it's Elsevier, whether it's open source, and so on and so forth. So right now, you cannot, we don't base the analysis on the full article. We base it only on the metadata and the abstract.
So the keywords and
yes, the keywords, the key, everything in metadata, including the journal, the title, the author, everything in the year, and so on. And this is the first thing that you use to do the deduplication. And then after that, we also we immediately extract the abstract and upload the abstract of the paper. The full article, there is no reason why we couldn't, and we do it in studies that are within an enterprise, but because of subscription, who pays for the article and copyright?
It's an analysis because I read into that problem.
Yes.
So,
Yes.
we were doing, well, not similar, but somewhat similar study.
Yes.
And the library said, you're downloading too many papers.
Yes. 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 Now let me tell you something else. We have a group of people that want to commercialize this for patent reviews, for legal use. That in patent reviews, you can actually download the patent from the patent office. So in that case, you can base it on the full text. But in published articles, you have this problem of copyright and so on. See how?
So I'm curious about the role of the reliance of users, human intervention, and do you foresee this getting them totally out of the loop?
No. I'm so glad you asked this because, in fact, at breakfast, Muqbil and I were talking about this. This is sort of human in the loop, like Hilda, before Hilda came about. So this system relies 100% on the user. The user is never out of the loop. In fact, legally or by protocol, in doing systematic reviews, it's the responsibility of the person who's running the clinical trial. The protocol would not allow the system automatically to make the decisions. So what we do, we learn from the first, say, 100 decisions that the user will use. Then we generate the ratings, and then we go back to the user and display the ratings in order. And they have to, even if they go to, say, 20 articles at a time, using this keyboard, you say, you select 20 and you say E for exclude or I for include, but still at the end, it's the user that has to make the decision. So what we do is, we give you the tools to do the reviews much faster, to go through, let's say, 2,000 articles in a week rather than taking a year to go through them. So it helps quite a bit. Minimum time saving, 50% is what users report. But the user is always there. The final decision has to be made by the person who's responsible for that clinical trial, because they have to sign their name on it and they publish the paper on it. But then there is this collaboration between different reviewers. So we open the system. I can invite you to be a second reviewer, and then we compare the decisions together.
So could you explain to those who are outside the medical field what is the connection between clinical trial and
Yes. Yes. So you start with typically I suppose this is in every aspect of science, but in this particular thing, you start with a hypothesis, you start with a question. And you want to run a clinical trial to answer a specific medical question. For example, whether there is enough support that obesity has an implication on heart disease, or whatever the question is. In order to support this question, there is the protocol that you have to run through. And one of the things that you have to go through is you have to do the systematic review. That is, you have to do a review of the literature. There is systematic and there is verified. So you have to keep track of the literature you went through, how you made those decisions, what you base those inclusion decisions or exclusion decisions on, and so on and so forth. So the systematic review is one step in running clinical trials. And only thing we don't do everything with systematic reviews. The only thing that we do is to help the domain expert, the physician or the person running the clinical trial, do that job faster, do it more efficiently, and do it more accurately. Because instead of them rushing through, the system helps them pick based on keywords.
So the focus on Rayyan is the hypothesis in the medical domain.
Yes.
That's a clinical trial.
Yes.
And then the scientific articles are just
The support.
Are the support
Yes.
for this central hypothesis.
Yes.
Could this be extended to other scientific fields?
Yes. In fact, I'm glad you asked. We are finding, like I said, because I'm trying to take something that takes 2 hours into 20 minutes, I kind of mumbled a little bit. So we find some very interesting uses, because we keep track of like, for example, I receive alerts every day on how the system is used. People are using it in marine biology, people are using it in fisheries, in construction, and so on. And in fact, people are using it as a way to do literature review. So you can, just imagine if you want to do a literature, like I work in data quality and entity resolution. if I want to run through all the literature, this would be a very good way of doing it. Like I said, there is a group of people that want to commercialize it in the legal domain for lawyers going through patents and so on. And you know, I just thought I would talk about something other than you will hear about data duplication in ICT. Okay?
So I guess we have to.
Thank you.